irrational numbers. Okay, why am I learning it? I am learning about rational and irrational numbers so I can extend my thinking about fractions, decimals, and whole numbers. We use these numbers, I'm going to abbreviate, outside of math class in areas such as measuring and cooking. How will I know when I've learned it? Well, when I'm able to classify rational and irrational numbers, when I could find the square root of a number, when I could find the cubed root of a number, when I can compare rational and irrational numbers, and when I can order rational and irrational numbers. Okay, so again, if you need to at any time, just stop the video so you could fill in your notes. Okay, rational numbers, what are they? Rational numbers are numbers that can be put into a fraction. Keyword here is can be put into a fraction. So any whole number, whether it's positive or negative, so like 3 can be 3 over 1. Negative 5 can be negative 5 over 1. So we could put any whole number over 1 to make it a fraction. Therefore, it is a rational number. If it's already a fraction, then clearly that also can be a rational number as well. So any type of fraction is a rational number. And then any type of terminating decimal. So if the decimal has a clear end to it, it is a rational number. Okay, so rational numbers can be fractions. Irrational numbers, they are numbers that cannot be put into a fraction. So anything with pi squared, 2 divided by pi, anywhere you see the pi symbol, that is an irrational number because it never ends and it always repeats. Non-terminating decimals, these are decimals that don't end. So like an example would be pi, that 3.14 number that keeps going on forever and ever and ever. And then we have non-repeating decimals as well. So a non-repeating decimal would have no sequence of digits that are repeated, but it goes on and on and on. So it continues endlessly. And again, pi is an example of that because it just keeps going and never ends. So pi is a non-terminating, non-repeating decimal. All right, a terminating decimal is a decimal that has a clear end. So like 0.25, if we think of like quarters, 25 cents. 0.75, 75 cents, 0.125, anything along those lines, it has a clear end to it. A repeating decimal is a decimal that has a pattern of digits. Okay, so typically you'll see this bar over the number that's repeating, so that is 0.3 repeating, or 0.333333333, and it never ends. Another one could be 0.125, and the 125 repeats. So 0.125, 125, 125, 125, and it keeps going forever. Non-terminating and non-repeating decimal is a decimal that continues endlessly and has no repeating pattern of digits. So we already talked about this. This is pi as an example of that. Okay. All right, then we also have a square root. Square root is a value when multiplied by itself, it gives the number in the symbol. So first, let's talk about the square root symbol. So right there is a square root symbol, and that's actually called a radical. So if we have the square root of, let's say, the number 4. Okay, so we need to think, what number multiplied by itself is going to give us 4? Oh, well, 2 times 2 is going to give us 4. So the square root of 4 is 2. So the square root of 4 equals 2. We could also think about it like the square root of 25. What number times itself gives you 25? Oh, 5 times 5. So the square root of 25 is 5. Cubed root's a little bit trickier. So a cubed root is a value when multiplied by itself 3 times, it gives the number in the symbol. So our cubed root sign, we still have our radical sign, but we have a little 3 perched up there. Okay? So let's think about the number 8. So one number multiplied by itself 3 times is going to give you the number 8. So we got 2 times 2 gives me 4. 4 times 2 is 8. So the cubed root of 8 is 2. Okay, same thing with like 27. What times itself 3 times is going to give me 27? 3 times 3 times 3. So the cubed root of 27 is 3. Okay? So if you need to pause the video to fill this in, go ahead. Okay, so now we're going to determine if a number is rational or if a number is irrational. Remember, we said rational is going to be a fraction. Irrational is not going to be a fraction. So we have negative 22. So we know negative 22 is a whole number. And in your notes, we got done saying that we could put any whole number over 1 and it will be a fraction. So if it's a fraction, it's a rational number. So negative 22 is a, is a rational number because it can be a fraction. Okay, so that's the key here. We're trying to see if these numbers can turn into fractions. 0.2. So on your calculator, do me a favor, put 0.2, hit the second button, hit the PRB button, hit your equals, and does that turn into a fraction? Sure does. It is 1/5. So 0.2 is a rational number because it can be a fraction. Okay? So then we have 3.9427. So we're going to put that in the calculator, 3.9427, 9427, 9427. We're going to hit second PRB. And see if that turns into a fraction. And it does. So yes, it is rational. because it can be a fraction. Next one, 3/4. Well, 3/4 is already a fraction, so 3/4 is rational because it is a fraction. This one is supposed to be pi squared. So anything with pi, we already said, is irrational because it cannot be a fraction. And then we got 0.051236789. So if we put that in our calculator, 0.051236789, we hit second PRB and then equals. It does not change to a fraction, so this is an irrational number because it cannot be a fraction. Okay, if you need to, stop the video to fill in this section of your notes. And then there's practice problems. So you're doing exactly what I just did, determining if the following numbers are rational or irrational. Explain why or why not. So go ahead and pause the video so you can get answers to that. All right, let's take a look. We have the whole number 15. So you should have 15 is rational because it can be a fraction. Okay, remember any whole number we could put over 1. 0.5 is rational because it can be a fraction, which is 1/2. 3 times pi is irrational because it can't be a fraction. 1/2 is rational because it is a fraction. 0.893467 is irrational because it cannot be a fraction. Okay, so those are your answers. Just double check it with what you have. And then we're going to move on here. So converting fractions to decimals. So let's figure out how to put a fraction in our calculators. So in order to put a fraction in your calculator, you do your top number, you hit the A, B slash C button, and then you put in your bottom number, okay? So to put a fraction to a decimal, you do top number, the A, B slash C button, bottom number, then you hit the second button, which is the purple in the upper left-hand corner, PRB, and then the equal sign. Okay? I'm showing you this way so it can be consistent when we turn then decimals to fractions. Okay, and there is also a video that is posted to show you where these buttons are as well on your calculator if you're unfamiliar. Okay, so let's convert these fractions to decimals. So for 5/8, I'm going to type in 5 AB/C 8. And then you're going to hit second PRB. And we should get 0.625. So 5/8 as a decimal is 0.625. Okay, for 1/10, got 1 AB/C 10, second PRB. So we get 1 AB/C 10, second PRB equals, and you should get 0.1. Okay, then for 3/16, 3 AB/C 16, second PRB, and we get 0.1875. Eight 25ths. So we get 8 AB/C 25, second PRB. Then we got 0.32. Then 17/20, 17 AB/C 20, second PRB. Okay, so go ahead and do the bottom. 3/5, 7/9, 4 2/3. So for this one, you need your whole number separating your fraction. All right, so your answer should be 0.6 for 3/5, 0.7 repeating, and then 4.6 repeating. Okay, for those repeating numbers, we're not going to write out all of the digits. We're just going to use the fraction bar over the number that is repeating. All right. Then we're going to figure out how to do the opposite. Change our decimal to a fraction. So we're going to put our decimal in the calculator. So we're going to put our decimal in the calculator. And then you're still going to hit your second button, PRB button, then equals. Okay, so if I have 0.25, I'm then going to put in second PRB equals, and it'll change it to a fraction of 1/4. If I have 0.3 repeating, this one's a little tricky because you have to put in many threes because it's repeating. Okay, if you just put in 0.3, it's going to give you 3/10. That is not the same. Okay, so once you have your decimal in there, it'll still be hit your second button, your PRB button, and then your equals, and we're going to get 1/3. Okay, then we're going to do 2.75, second PRB equals, you're going to get a number that looks like that. Okay, so that means you have a whole number. That's your whole number. We're not going to write that U because it's 2 whole units and then 3/4. Okay, you never see that U in a number, so just leave it out. Okay, so you guys are going to go ahead and do 0.5, 0.125 repeating, and 3.8. Okay, so if we put 0.5 in our calculator, we should end up with 1/2. 0.125 repeating is 125 over 999. 3.8 will give you 3 4/5. Please leave the unit sign out of that number. Okay. All right, so then we're going to order some numbers. So in order to order these numbers, we need to change everything to decimals. Okay, this is the easiest way we can compare numbers is in decimal form. Okay, so we're definitely going to use our fraction, second PRB, second equal sign. Okay, so if we have 1/2, 1 ABC 2, second PRB equals 0.5. Don't need to do anything to -7 besides bring it down. 0.4 is a decimal, bring it down. -2.3 is a decimal, bring it down. And then we need to convert 1/3. So 1 ABC3, second PRB equals 0.3 repeating. Okay, when we rewrite these and put them in order, we are using the original numbers. You are not using the decimal conversions. You are using the original numbers. So let's start out with our smallest. So our smallest number is going to be our biggest negative. So -7. Then we're going to do -2.3. Then it looks like we have 1/3. We have 0.4. And then we have 1/2. Okay, so notice I used the fractions in your final answer. I did not use 0.5 or 0.3 repeating. Okay, so you guys are going to go ahead and do practice 4. So first thing we need to do is change those fractions in the decimal. So go ahead and pause the video, and then once you're done, we will go over them. All right, so let's go ahead. 1/6, we got to convert that to a decimal, which is 0.16 repeating. Using -4, using -0.9, using 0.94, using -2.4, changing 3 1/2 into a decimal, which is going to be -3.5, and then 5. Okay, least to greatest, so we need the biggest negative, which is -4. Then it looks like, oops, nope, we have -3 1/2. Use your fraction. Then it looks like we got -2.4, -0.9,